Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Muhammad Fazli from RCS 1434B. Today, I want to explain the application of homogeneous system in chapter 4, 5 and 6. My groups and I was found in these three chapters have 4 application of the homogeneous system. Okay, for the first application is linear independence. Okay, let's start. I will tell the definition of linear independence. The set S in a vector V are said to be linearly independent if C1 V1 plus C2 V2 and so on equal to 0. This is called zero vector. Implies that all the scalars Ci equal to 0, which is I equal to 1, 2, 3 and so on. Next, the set S in a vector space are said to be linearly independent if there exist scalars C1, C2, which is these scalars not all 0 such that C1 V1 plus C2 V2 equal to 0. Okay, this zero vector have three states, which is V equal to R3, V equal to P2, V equal to M2 times 2. Okay, for this linear independence, it have one theorem, which is linear independence and matrix singularity. Okay, let me explain. Let A be the coefficient matrix of the linear system obtained from the linearly combination of vector in a curly bracket V1, V2, V3, and so on in set S. The vector are linearly independent if and only if A is non-singular, that is, determinant of A not equal to 0. Theorem 1 gives another method show that S equal to in curly bracket V1, V2 and so on is linearly independent, that is, by showing that determinant of A is not equal to 0. Okay, that is the explanation of the linear independence. Okay, I will do in the second part the one question about the linear independence that involve the homogeneous system.
Okay, let's move to the second part, which is this part. I try to do the linear independency question. The question is V1 2 to 1, V2 negative 4 6 0, V3 1 0 1 is linearly independent. Then the first step is form a linear combination, which is A 2 to 1 plus B negative 4 6 0 plus C 1 0 1 equal to 0. Then this is the homogeneous system. This is the form of homogeneous system. Okay, then this linear combination will be independent if it equal to 0. Okay, the metric representation for homogeneous system is like this. Then we change it into augmented matrix and we solve it by using ERO, and we will get like this. Okay, then the conclusion is the solution is trivial, that is A equal to 0, B equal to 0 and C equal to 0. If we calculate the determinant of A, then A equal to 1. Therefore, the set is linear independent. Okay, this is the application of homogeneous system, which is the linear independent. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fakir Syabani bin Muhammad Nasir from class RCS 1434B. For now, we move on to null space and nullity. What is null space? Null space is solution space for the homogeneous system Ax equal to 0. And what is nullity? Nullity is the dimension of the null space. To be more clear, we look forward to the example. This is the example of the question. Given A equal to 1, 1, 3, 1, 2, 1, 5, 4, 1, 2, 4, negative 1. Okay, so the question is, find the solution space for Ax or the null space A. Ax equal to 0. So this is the formula. Okay, so we rewrite the matrix given 1, 1, 3, 1, 2, 1, 5, 4, 1, 2, 4, negative 1. And x1, x2, x3, and x4. And the result will be 0, 0, 0. Okay, so first step is we need to reduce this matrix A in the row echelon or reduced row echelon form by using ERO. So we will get this. So we put x1, x2, x3, x4 according their column. Then x1, we see column x1 and row 1. So we get this 1 x1 plus 2 x3 plus 3 x4 equal to 0. And for the row number 2, we will get 1 x1 plus 1 x3 minus 2 x4 equal to 0. For the next step is solve the system using back substitution. Okay, so for this step, we need to let the free variable, which is x3 and x4, okay, because x3 and x4 come after the leading variable, which is x1 and x2. Okay, so we let x3 as s and x4 as t. So we substitute s and t into this equation. We will get this and this. But the last step is the solution of Ax equal to 0 is x1, x2, x3, and x4. This is because the column of matrix A has 4 columns. So it will have x1, x2, x3, and x4 equal to this one is x1, x2, x3, and x4. We got it from here, x1, x2, x3, and x4. Then we simplify it into s and t. Next question. The basis for the null space is we just take the answer that in the bracket that we have simplified in the question above. So we just take this and this into this question for the answer. See, the nullity A is equal to 2. This is because the question above, the basis for the null space is we have only two matrix in it. So the nullity A is referred to the matrix in the null space 1 and 2.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Harith Akmal bin Razban and I'm here to present about kernel and what can homogeneous system relates to kernel. So how do we recognize kernel? Okay, it's easy. I'll show you. Okay, let's say that T V equals to W is a linear transformation. So how do we recognize kernel or ker T? The theorem is the kernel is a subspace of V. So this is how you recognize kernel. V and W. Let's say this is V that maps to 0. So this one is kernel. It is quite easy, right? Okay, so now we know that kernel is a vector, let's say V, that maps into 0. So that's kernel. So this is part 2 about other question that relates homogeneous. Okay, so the question is find kernel and basis of kernel. So here's the question: T x y z equals to x plus y and negative 2x plus y minus z. So the first thing is we must know about the theorem, the corollary. So the corollary is kernel is equal to the solution space of Ax equals to 0. Alright, let's just proceed. To find kernel, we must find vectors that is, I call it as V x, y, z such that PV is equals to 0. So we do like this. Okay, after that we solve the homogeneous system, and it will be like this. Okay, so then after we get this answer, we can solve this by using homogeneous system. So in homogeneous system, what we can do and what we must do is negative 2, we must let this negative 2 be 0. So how can we do that? So from row 2 we plus row 1, but row 1 times 2. So R2 plus 2R1 and whole answer must be recorded in row 2. So it will be like this. So after we get this, what we can do is we must make this tree to be 1. So the condition, so we must follow the condition like this must be 1, 1, 1 and 1. So what we can do to make this number from 3 to 1 is we must times everything from row 2 to 1 over 3. So then we will get this 0, 1 and negative 1 over 3. But the thing is, this number 1, the above number must be 0. That's the other condition of reduced row echelon form. So what can we do is row 1 minus by row 2 and replace it in row 1. So we get 1, 0, 1 over 3, 0, 1, negative 1 over 3 and equals to 0. So what we can do from this is we solve this by using homogeneous system. So homogeneous system, we got this x plus z over 3 equals to 0, y minus z over 3 equals to 0. So easiest way, we let the z on the right side, so x equals to negative z over 3, y equals to z over 3. So to avoid confusion, my bad for pronouncing it wrong, we can substitute z to t. So t is real number. So we got x equals to negative 1 over 3 and y is equal to 1 over 3t. X is negative 1 over 3t. My bad. Okay, so the kernel is xyz equals to negative 1 over 3t, 1 over 3t, and t. So x is negative 1 over 3, y is 1 over 3, t, and z is t. So we can factorize the t outside, and it will be negative 1 over 3, 1 over 3, and 1. T is real number. Then the question asks for the basis. So the basis of kernel is negative 1 over 3, 1 over 3, and 1. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahim Zamri. I'm from RCS 1434B. My matrix number is 2018678776. Today I'm gonna explain about eigenvalues and eigenvectors. That's all for my explanation for eigenvalues and eigenvectors. Thank you. As we can see the equation, AV equals to lambda V, which is the matrix is A. Both side V equals to eigenvector and lambda equals to eigenvalues. Now I'm gonna show you how to find eigenvalues and eigenvector in 2 times 2 matrix. First, given AV equals to negative 6, 4, 3, 5 and lambda V equals to 1, 4. How do we find eigenvalue and eigenvector? We do the matrix multiplication, and then we get negative 1, negative 6 times 1, 4 times 1, 3 times 4, 5 times 4, and then we get 6 and 24, and then we equalize both sides, which is 6, 1, 4 and 6, 24. Now we get both sides equal to each other, right? So we know the eigenvalues and eigenvector is true. Next, I'm going to show you how to find eigenvalue in 2 times 2 matrix. First, we should know that in the earlier equation, which is AV equals to lambda V, we use that equation to find the eigenvalue in the matrix. How? We add identity matrix into the right hand side. In the end, we should get A minus lambda identity equals to 0. As you can see from the below question, negative 6, 4, 3, 5 is the matrix, which is A, and lambda times by the identity matrix, which is 1, 0 and 0, 1 equals to 0. Next, we find the value by subtract both matrix. Negative 6 minus lambda, 3 minus 0, 4 minus 0, and 5 minus lambda equals to 0. Next, how do we find? We use the determinant method, which is AD minus BC. Next, we're gonna get a quadratic equation, and then we just factorize to get the eigenvalues. And finally, I'm gonna show you in how to find eigenvalues and eigenvector in 3 times 3 matrix. Just like the 2 times 2 matrix, we the given matrix A 2, 0, 0, 0, 4, 4 and 0, 5, 3, we use the same formula, A minus lambda identity equals to 0. So how do we use this? We times the identity with lambda, and then we multiply, we minus the matrix just like usual, and then we're gonna get this equation, and then we use factorization. The 2 minus lambda, we should get lambda equals to 2, which is one of the eigenvalues. Okay, next we factorize the quadratic equation. We will get lambda equals to negative 1 and lambda equals to 8. So we should get the eigenvalues 2, negative 1 and 8. So how do we find the eigenvectors? Just like 2 times 2 matrix. Okay, next I'm going to show you how to find eigenvector. From the previous question, I used matrix negative 6, 4, 3, 5, which is we get the eigenvalue for negative 7 and 6. Now we're gonna find the eigenvector for when the eigenvalue equals to 6, lambda equals to 6. Okay, next, as the equation we see, we multiply both with x and y, and then we get the equation negative 6 plus 3y equals to 6y, 4x plus 5y equals to 6y, and then we bring all to the left hand side, and then we get negative 12x plus 3y, 4x minus 1y. Okay, then we should get both equations should get y equals to 4x, which is equals to 1 4. And then how do we know the equation is true? We check both sides to be equalized just like the earlier equation, which is AV equals to lambda V. And then we do the multiplication just like the earlier, and then we get 614 620 equals to 624. So both sides is equal.